Hello everyone, this is another video from Siemens PLC training series, and today we are going to write two simple program in the Siemens PLC. So before we do that, so definitely you should go and install these software that we have inside the kit. So see this one, there is actually three DVD inside the box, so this is what you need for today. So if you install the old things that you have inside this DVD, so easily you are able to get whatever right now I have in my desktop. So if you install that, you will get these three software that we have, which is need TIA Portal -17 version. So yours maybe if you buy recently or later on, probably you should actually have the newer version. But whatever I have is version 17, which usually there is no big difference between the different version that we have. So let you close this and see how we could write the simple ladder logic that we learned in a previous video. So I click on that and see what I will get. So it's definitely takes few minutes, depending on your system that you have. So in my PC I have a lot of software. It is slow, so it takes actually a few minutes to boot the program. So just don't forget to plug in this small USB, which is the password that you have to your laptop, because it somehow unlocked the software. So this is actually what you see. So before we start to do anything, just connect these. Let I show you. So this side of the cable, this Ethernet cable, goes to the PLC that we have, and the other side of that goes to your PC. And also, if I could turn the other side, so you need these 110 input that able to turn on your PLC. So that I show in this way. So see, it's actually comes to this side that I have. So just be careful. This is 110 volt. Don't turn that around. So because it's very dangerous, maybe it's actually unplugged, and it's possible you're able to touch that. So we did that. We actually connect our 110 volt. We connect our network cable to the PLC, and we open these software. So you go to the open new project, you click on that. So you could put any names that you have. So I'm going to change the name to project 1. Here you could give the path. So I'm going to save on my desktop. I open the folder with the name of the Siemens, and I'm going to save that to that folder. You could actually go anywhere. If you click this, you could see it's actually give a place. You could actually select the folder that you want to save these program or project. So version, the name, so it should be fine. You go, it says already exists because I already have the project 1. So it's asking me, it's already exists. Do you want to put the different name? So let I do one thing. So I'm going to somehow delete whatever I have here and have this as my first project that I have. So now I should be good. So I say create. I shouldn't actually get any problem. It's easily go and create the project 1 folder and put whatever I'm designing inside that folder. So it takes a few minutes that it's able to create your project inside the folder that you specify for the program. So let's see what we are going to get. So as you could see, it's still actually creating that. Okay. So now you actually get this page. You are going to configure your device that you have. So I'm going to somehow configure that. So here you see there is add a new device. I click on that, and it should be, yeah, again, it's slow. It's take a few seconds. You get actually the list of the controllers. So see here, if you have the different Siemens PLC, different model, shouldn't be a big deal. You just find the model that we have, whatever we use with these training kits. So this is what we have, a 1200. We click on that. So even it's you need to know the name of the CPU. So you open the CPU, it gives you a too many models. So you could find the CPU number. So if I could show you again, hope this 120 volt that I have don't unplug, that I'm able to show this. You'd see. So see here. Here you could see the all information that you need. So here you see the CPU models, right? So this is the second line that you see. It shows the CPU, and you see the model. Mine is start with 6ES7212-1BE400XB0. Okay, so easily you could find that here, and you somehow find that here and put that number. So what I'm going to do, I'm not going to use that because I want to make sure about the right connection that we have. Let's do that. Definitely you could find that number here. So I'm going to do one other things. Here you see there is unspecified CPU, just in case if you don't know the models, let's do that and see if it works or not. So mine is start with 6ES72, which we actually checked that. So let's see if you don't know the exact number and you know just the beginning of that number. I select this, so it somehow put that the shape, but it's not accurate because it's don't know which actually model do you have. It's going to search connect to your PLC. Then whenever it find the right PLC, you see exactly the shape of the model that we have. So I select on specified, then I'm going to add it. So let's see what we are going to get. So again, it takes few seconds to actually go to the next page. I don't know, it's because of my laptop, which I have too many software on it and it's slow, or normally the software is slow, no idea. So yeah, still you see I'm waiting to get the new page, which it shows it's actually moving to the next page, and I got it. Okay, so here you actually see still it couldn't know what's the exact model because I put down a specified CPU. So then here there is a give you option, which is the detect. I click on the detect. I want to see my laptop could able to connect to the PLC and find or read the CPU model and find the right one. So here I use the first option, then let's see what it gives to us. So definitely it's not USB, so it should be this one, which is the Ethernet connection. So then we could actually here start to search. So that means it's going to be communicate with your PC. As you could see here, is communicate with PC as find the right model for your PLC that you have. So I'm doing this just in case if you are going to do with any other models of the Siemens, so easily you could connect and you should be able to detect that. So as you could see, it's actually find that. So you see the MAC address, IP address, and the CPU models that we have, which is exactly what we have. So even here it gives you a option here, so which is the flash LED. So for making sure you have the right connection between your PC and your PLC, if you click on this, it's starting to flash the indicator that you have on on the PLC. So see these corner that we have here, these corner, and these LEDs is starting to flashing. So I'm going to somehow check these check mark from here. It should be stop. So see, it's actually stopped. Okay. So that means easily you recognize that and make sure you have the right communication and they are able to communicate to each other. So whenever it's finish your search, then you say detect. So it's probably talk about some security questions. So let's see, consider as a trusted communication. So I click on that and see what it's take us. So should be able to detect that. So these pictures should be changed. Yeah. So see, so it's able to detect that this is exactly the same PLC that we have. So that means easily it's able to detect and bring the right one that you have. So it's good so far that you see what else we could do. So yeah, this is the second Windows. It's actually pop up. So it's talking about the setting the password to connect to the PLC. Probably you need to have these password, which is make that more secure. So I put the next. So here I say no access, complete protection, full access, no protection. Yeah, it is depend on your needs. So I just want to. This is just education purpose. I don't think it should be necessary to set up any password because it's a lot of work, right? So whenever you want to do anything, you should go and enter your password. So again, if you like, you could actually put some password there. So then, so as you could see, we are good. We find the right PLC that we are using. So then you come here on the program blocks and click on the main, which is the place that you should put your ladder logic. So I click on this. So as usual, it takes few seconds to show up, and this is the place that you need to put your ladder logic. So as you could see, this is your page that you could add it. So here you have the all samples that you need. So in the previous video, I introduced this, which is the conductor normally open. So see, this is, if I could, it says some comment normally closed conductor. So even it actually could explain how it works. So this is the coil, the sample that we have. So these are actually the other boxes. This is for using the parallel. So I'm not going to talk about these three because whenever we have the progress in the course, so I'm going to explain them. For now, I already introduced these three. In the previous video, I'm going to just use the simple. So again, in this video, I'm focused just give you idea about how you could put the ladder logic, how you could implement that on the PLC and see the result in the simulation and also on the PLC that we have. So let's put exactly the same logic that I explained in the previous video. So if you go and check the previous video, we had this simple logic, right? We put the normally open with the coil and normally close with the coil. So if you didn't watch the previous video, please do that because you need that basic knowledge to understand the rest of this video. So let's do that. I'm going to implement exactly the first one. So see, this is the normally open with the coil. Let's do and implement that. So I just drag and drop the sample that I have. I put there. So I have exactly the same sample, which is normally open, and also I need the coil, right? I put the coil in here, okay? So this is exactly the same thing that I explained in the previous video. I make that with the drag and drop these two samples that we have. So now you go find the PLC that you have, which is these guys that we have. I minimize that here. I just bring that up again. You click on this, which is somehow have both of them side by side. So I'm going to probably maximize the picture because I need it. So see, this is exactly the same PLC that we have. Here you see the indicator, the all 8 inputs that you have, and here your output with their number that we have on the PLC. So now definitely you should somehow specify. So this is the input, right? So I mentioned the power comes from left to right. So the inputs, which is the conductor, is on the left and the output is on the right side. But here you should say which of these contactor connect to the which inputs. So you have actually these options 0 to 7. Same for the output, which is your coil. You have option, all these option is here. So you should definitely set to one specific input and output. So for doing that, so I'm here connect to, so see it's clickable. So that means if I drag this IO0 that I have and put it here, it's actually somehow set that specific IO. So see, it says this is IO0. So I actually set that for these contactors. If you don't like these names, put these name tag 1. If you don't like, just double click on the same place here and change these names. So maybe input 0 is make more sense for me, digital input 0 on the PLC. I suggest put input 0. I say okay. So see, it's changed the name here, and even here, I don't know, it is clear here. It's very small, but definitely it shows these IO0 that you have in your PLC. You actually set that to these normally open contactor. Okay. So you do the same for the output that you have. And my coil is output. So see here, these the output that we have. So I just drag this, just put these here, which somehow telling this coil will be in output 0. So again, it see these 0.0. So that means the digital output 0 somehow set for these output that we have. So again, if you don't like the name, which is usually put tag something, so I'm going to change that to maybe output 0 is make more sense. So I say okay. So we see output 0, 0. So it looks fine. So see what I did. I have these ladder logic. So I actually set one input 0, IO input 0 that I have on the PLC comes here, and the output 0 for the coil. So let's minimize this. So now let's see how we could actually load that. So if you comes here, there is some compile similar with the microcontroller, right? Whenever you write a program in the microcontroller, you compile that, then load it. So the PLC inside you have a CPU, so it's the same. Let's just compile this. So I'm going to compile it. So then you need to use this small icon, which is you load whatever you have in the ladder logic. So it says, because I already did that before, it says I'm overwriting. I say yes. So it's actually load the ladder logic that you have. So if is done, so whenever it's done, you just able to check this small guy here, which is the monitoring. So that means somehow it shows you the live stream of your program. So that means somehow it simulate what you have. So as you could see here, let's see if we do this. So see, it's put actually somehow yellow here, which is somehow tell us it's actually in the live stream. So here, if you click on this testing, then you have these run here. So somehow you need to run that on your CPU. So that means change to CPU to the run mode. So that means like now I have the online streaming of the ladder logic that I have. So see, this one is interesting. So see, right now it is it shows everything is green. So I'm going to turn off or put the 0 in my IO pin input 0. So you tell me what should be happen. Whenever you have the 0, it should be off. Whenever this is 1, it should be actually off. So see, so right now this is the IO 0 that I have on my PLC is 1. So then the output is 1. So if I change that to the 0, so see I changed that to the 0, it's actually changed the color to the blue, which somehow tells you this is off. So I'm not sure I'm able to show this to you. So see, let's start from here. So I put these simulator here which connect this. So this little guy that I have here is connected to the I0. So see if I change these, did I see I'm doing the right one or wrong one? Yeah, it is this small guy here. So if I do this on and off, so let's see, okay, this one. So see, with changing this to the on and off, so the first thing is these indicator that you see here. It shows me what's the status or what I have here and IO0. So see, these LED is on. So this is IO0. So that means right now I have IO0 is 1, okay? So if it's 1, back to the ladder logic. If it's 1, this is normally closed, so that means if is 1, it should be actually closed, and the IO should be 0. So here you see the IO. See these little LED here. This shows this line is somehow is your output. Okay, so this is output 0. So that means 1 give you 1. This is what you expect. Okay. So now I'm going to change that to the 0. So I put that on the 0. So what logic says? The logic says if this is 0, this is normally open, right? So it is normally open. So that means whenever you have 0, which is the current case, it should be normally open. So that means if this is open in the 0, so there's no actually power here, that should be off, okay? So again, easily you see how it's working. So see, I'm having here, so the IO0 is 1, so the output is 1. Even you could see on the simulation, on this here on the what we call the online streaming of that. So see, whenever it is on, and then it changed to the other color whenever it is off. See, right now is blue on the program. It means in the same time you exactly could see both of them. So again, the IO0 is 0, the is open, so the output is 0. You see on these LED indicator and also in the simulation. So whenever it is on, okay? So we actually did the first program. So let's do the second one. So here there is actually the second network. You could have the second one again. If you back to here, you see this is the second program that we want to implement. So this is normally closed. So let's see what it tells. It says normally closed. If the input is, this is normally closed. Input is 0. This is on. If this is 1, it should be actually off, right? So the 0 on 1 should be off. So back here and implement the same thing. So easy. So I just drag and drop these normally closed one here. So I have it. So then I come here. I need one coil. I put that here. So similar with what we did comes to the PLC here. And you tell me what we should set up there. So we put IO0 for the first one. So let's do IO1 for this second one, set and ladder logic. So it says tag 1. I'm fine that. Also, you could change the name if you don't like it. So see, it says which IO pins you give these contactor. It's IO1. So same thing for the output. So if you comes here, and here is the outputs that you have, and drag and drop the second output, which should be output 1. So see 0.1, this is output 1 for this. So then you should be good. So I'm going to minimize this. So do the same thing that we did before, just compile it. It's actually no error, so you just load it. So you load it. Yeah, it's actually, whenever you load, it's load, which I see on the PLC, it's working because it turned on the second one. So again, so if you don't see these yellow things on all these sections, so you need to click on these guys, which is a monitoring, somehow is the simulation of what you did. So I'm coming to the second one. So see, this is the first one, this is the second one with the name of the network too. So let's see, I'm going to, on the PLC, turn the second one on and off, and see it's working, right? So right now in input 1 is 1. So this is normally closed. So whenever it is 0, should be closed, and it should be on. Whenever this is 1, it should be off. So right now I have a 1 in IO1, so it's actually closed that. So if I turn that to the 0, so which is right now my input 1 is input 1 is 0, so it's actually turned on this. So again, I'm changing that toggle switch that I have. Easily you could see the live stream of that. So if I show this to you again, I hope this 120 volt not unplug from here and don't have any problem with that. So really I have just one camera here, which is tough to do that. So let's see if you could see that or not. So I don't know, maybe this way is more better. Okay, so let I just move that a little bit. So see what we have right now. So we have two IO switch, which is here. So this is IO0, this connected to the IO1. Okay, so with this simulator that we have, with changing this toggling switch, I could give 0, 1 to input 0. With the second one, I could give 0, 1, which is 12 volt, to the input 1. So see here, now I give both of them 1. So see right now both of them is 0, because these LEDs here is 0, right? These LEDs shows me what I have. So right now both 0 and 1 is 0 because that LED is off. So now back here, if I give the both 1, so see I easily could give both 1. So let's try the second ladder logic that we have. So we already test this one. Let's do this. So you tell me, based off these LED that you see here, what's the value on the IO pins 1 is 1, right? So I have 1. So what you expect? So see, if you have 1, this is normally closed. In the 1, it should be closed and the output should be 0. So even you check the output, just be careful. Whatever you have is here is on is output 0, which is the first program that we wrote. So output 2 is this one, which is actually off. So again, I'm going to change it. So see, I'm changing that to the 0. What you expect to have in the 0 based off this is normally closed. If it's 0, this is closed, and this is on, which you see the same thing. So as you could see, you could try both of them. Here you have indicator, it shows the value that you have for your input, and here you see the value for output. So let's do just double check that for both of them. Let's do for the first one, these guys. Just watch in the same time the simulation and also what's happened on your PLC. So this is a little guy. So you tell me right now what I have in input 0. So see, right now I have 0. Right now I have 1, right? Based off these small LED that is going to turn on and off. So let's do check. Input 0 is 1. What should be happen? This is normally open. So that means normally open means whenever it is, let I just see, it is 0 or 1. Yes, right now is 0. So see, right now is 1 and this is 0. And even you could see here in simulation what's happened, right? So take a look to the first ladder that we have. So right now this is 1. So normally closed, normally open. So whenever it's 0, it should be open and the output is 0. You see on the simulation and also you see on the reality, right? So same for these guys. So I don't know, maybe I put these off and just try work with the second one. Let's do check the IO1. So see what I have in IO1 right now is 1, right? So it is 1. This is the second one, right? IO1. So see, this is IO0, IO1, output 0, output 1, okay? So don't mix up these two. So let I see here what I have right now. I just double check that. Yes, that's I have IO1 is right now. So see, even whenever I toggle that, you see the second. We are on net. This is network 2, which is we have IO1 and digital output 1. Okay, so I'm touching this second toggle, which is connected to the I0. So I1, sorry. So see, I1 right now is 1. So this is normally closed. So whenever it is 0, normally closed, it's closed, it is on. Even you see the IO LEDs, which is on, and also you see this from here. So that means we could actually check from the both side. So now I'm changing the input to the 0, which you see the LED is on, and definitely whenever it is 1, the switch, the contactor is open and the output will be open. You see actually here there is no output. 1 is also closed. Okay, so yep, so that means this is very cool way that you could see the simulation and also you could see the same thing on your PLC. So thank you for watching this video and see you all in our next video.